Chapter number 13, the role of quality in performance measurement. Lecture number 13.6, quality practices, Six Sigma. Hi guys, let's start our lecture with Six Sigma. Now, before starting this lecture, I'd like to put out a point in front of you guys that the portion of Six Sigma that is covered for you in APM syllabus is pretty straightforward because ACCA's focus is about how to implement a Six Sigma and what are the advantages and disadvantages of that and other stuff. They don't want you to actually get the core concepts of Six Sigma. Like, they don't want you to be actually expertised in Six Sigma processes, because Six Sigma itself is a separate certification course. There are various levels in Six Sigma. You have white belt, you have yellow belt, you have black belt, you have green belt. So there are various steps in Six Sigma itself. So your syllabus, your content of your APM perspective covers only a limited aspects of Six Sigma. Okay, so I will try to restrict myself to that particular content instead of going into the real practical in-depth analysis of Six Sigma and all. I'll try to restrict myself because I don't want you to be overburdened with too much information. Yes, it is good to have practical examples. Yes, it is good to have practical knowledge, but too much information on one particular area of your syllabus is very hard for the students to grasp, considering that you have various portions to cover. You have a vast syllabus to cover. So if I focus only on Six Sigma too much, that will be productive. So I don't want to do that. So let's I'll try to restrict my explanation to your syllabus content area. Okay, Six Sigma is a very huge subject. Now, so first of all, what is this concept? We are going to talk about Six Sigma, right? Six Sigma. Okay. Now, see, we know six. Six is basically the number. Okay, now what do we mean by sigma, sir? There are two types of sigmas. If you understand Greek letters, there is the upper sigma and there is the lower sigma. Like, just like in English alphabets, we have uppercase and lowercase. So you have uppercase sigma and then you have lowercase sigma. Now the uppercase sigma is used for sum. It is, in short, we call it as summation of, right? And the lowercase sigma is also called as deviation, or we usually call it as standard deviation. If you are comfortable with statistics, sigma is a word which, the lowercase sigma, we use it with standard deviation. Now, just to give you a logical explanation of what Six Sigma is truly. Okay, see, if you see your textbook content, if you see your ACCA content, there is nothing given about what is sigma and what is Six Sigma. They just talk about, yes, what is Six Sigma is given, but they don't talk especially in depth about sigma concept. Okay, so for students who are good with statistics and who already know what a standard deviation is, skip the lecture. For next 10 minutes, you can skip the lecture, no problem. If you don't know what standard deviation is all about, or if you think that, yes sir, I need conceptual clarity with respect to that, so follow this lecture. Okay guys, chalo. So now, sir, first of all, I hope you guys know what is mean. Okay, mean is also simple language, we call it as average. See, for example, just for an example, I am considering, what shall we take? Okay, we will take the cost per unit. Okay, in our factory, what we are doing is we are calculating daily cost per unit. On every day, we are calculating what is the cost per unit that is produced on that particular date. Okay, fine with the example that I am taking. We are just basically calculating the cost per unit in my factory every day. So I did for day 1, 2, 3, 4, 5, 6, like this. Okay. Okay, let me do one thing. I'll just take an Excel sheet so that this will be much more easier for me to do the math. Arey baba. Yeah. So let's just say we'll start with day cost per unit. So I'll take 1, 2, 3, 4, 5, 6, 7, 8 days. And what we are doing is I'll just fill some random numbers between, let's just say, 10 and 15. Okay. Fine. 10 and 15 would be a little too close, yeah. So let's just go for 10 and 25. Okay. So these are the cost per units in my factory for the first 8 days. Now what we need to do is, I hope you guys know how to calculate sigma. So sigma is calculated as, why is this not working? So I have to go to draw. Okay. Yeah. So sigma is calculated as, okay, this is not okay. Okay. Sigma is equal to, how do you calculate the standard deviation ma? It is sum of x minus x bar whole square divided by n under square root, right? Square root of sum of x minus x bar whole square by n. Here x is the value, that is a variable, x bar is the mean, and n is the number of iterations, means number of repetitions that are done. So sigma, the standard deviation, is calculated as square root of x minus x bar whole square, sum of x minus x bar whole square by n. Okay, so now by using this formula, let's just calculate the standard deviation for this particular scenario. So first we need x, right? Okay, now it's working. So first we need to calculate the what do you call it, average, right? Mean is the average, so I'll call it x. Okay, let's just put a, how shall we calculate? Okay, we'll put a hyphen on top of that. Okay, yeah, instead of x bar I'm putting this because I cannot put x bar here, okay, in Excel, so I'll keep this as the x bar. So how do I calculate? Is equal to average of this all numbers, right? Okay, so I got the x bar, so the average or the mean is basically 16.625. Okay, now it is working. Okay, so now we got x bar here. X bar is how much? 16.625. So now let's calculate x minus x bar. Okay, so how do I calculate that, sir? X is 19 minus x bar is 16.625, correct? Okay, let's just put square as well here. Okay, just to reduce the, what do you call it, number of columns. Okay, this also I am doing square as well right here itself, raised to the power of 2. So this is x minus x bar squared, correct? Okay, else let's do first x minus x bar, then we will square it up. Okay, so this is x minus x bar. See, this has negatives as well, which is absolutely possible, ma. See, on a mean, that means on an average your cost should be 16.625, but on day 2 you are only producing it at $12. That means you are saving 4.625, so that is showing a negative. Here it is a additional cost of 2.375, here it is a lower cost of 4.625. So negatives are also fine. To eliminate the negatives, we square it up. So how do I square it up now? X minus x bar whole square, right? So this is equal to the power of 2. Okay, then what are we supposed to do? We got x bar, then we got x minus x bar, we got the square of it, then we need the sum of that. So sum of x minus x bar, right? So that will be is equal to sum of all this. So sum of x minus x bar is 179.871. Next, what am I supposed to divide it by n? What is n here? We are doing 8 number of iterations. So divided by 8, right? So 179.875 divided by 8, that means 22.4844. Then what am I supposed to do? Square root of that, right? Okay, so how do I do a square root of that? This raised to the power of 1 by 2. Okay, so square root is square root of this is 4.74177. Okay, see, or else you can also use the formula SQRT. SQRT is square root directly, 4.74177. So what does this actually mean? See, for you to actually understand this, I'll just give me a moment. I'll do one thing here. Where are you, sigma? Okay, I don't think I'll be able to find this right now in the lecture, during the lecture. There's so many symbols here, yeah. These are breaks: alpha, beta, gamma, theta, delta. Yeah, here is sigma. Okay, so we got the sigma here. Cool. Chalo. Now, so what does this actually mean? This sigma actually means. So to understand that, you need to take a graph, ma. Okay. Yes, unfortunately, these are all not covered for you in syllabus. So just for your understanding purpose only, I am covering all this. If you want to skip, you can skip. Absolutely no problem, ma. This has nothing to do with your APM. I'm just trying to give you a glimpse of how Six Sigma actually works. Okay. You don't need to know all this, to be very honest. Okay, so now if I take a graph and start plotting this, okay, I'll start with the lowest value. Maybe I'll start with 10 and end with 15. Okay, so we'll start with 10, 11, 12, 13, 14, 15, like this. If I go up to 25, okay, and then what I need to do is I need to start plotting these values: 19, 12, 16, 22, 25, this all. Okay, let's do one thing. Instead of actually drawing the chart here manually, why don't we just take a chart directly from Excel itself? That would be much more convenient, right? So we'll just go to insert and we'll insert a histogram maybe. Come on, give me something nice. No, not this. I want a histogram. Where is histogram? This photo. Yeah. Okay, we'll just go with a clustered column. Yeah, we'll go with this. Okay, nice. So we got the chart here, and now if you see here carefully, what I just did is nothing but I just calculated my sigma and I plotted all my daily costs. This is day 1, day 2, day 3, day 4, day 5, day 6, day 7 and day 8. So I plotted them on a chart. And now what I am going to do is basically, what is my mean here? My mean is 16.625. 16.625 is somewhere here, correct? Okay, anyways, so we have 16.625 somewhere here. Now what are we supposed to do? What we are going to do here is, okay, 6 sigma. What is our sigma? Sigma is 4.74177. So what I'm going to do is, from 16.625 I will add 4.474. okay, so that will be how much? 16.625 plus 4.74177, that is 21.367, again plus 4.74177, that will be 26.108. Next one is 30.85. See, what is our maximum highest cost here? Highest cost itself is only 25. See, even if I just go with 3 sigmas, okay, see my sigma is 4.74177. I just went with 3 sigma here. Okay, this is first sigma, this is second sigma and this is third sigma. Even by third sigma itself, okay, my maximum value is within the third sigma itself. I'm not even going till 6th sigma. So what are we trying to understand? Okay, see, first of all, what does sigma actually mean, ma? Sigma means the deviation from the mean. Deviation from the mean. It means, in another language, if suppose this is my plotted chart, and if I plot all my values like this, whatever are my values, and if this is my mean for an example, okay, see, for example, my mean is 10 and I'm saying that x bar is 10 and sigma is 2 for an example. Okay, so any given point in this particular plotted line or plotted histogram will be within a standard deviation of 2. Okay, it means it is either within 8 or within 12. Okay, sir, but these are above and beyond. On an average, we will consider. Maybe there are some more points in between these. So the average is coming into between this two deviation range. I hope you are able to understand, ma. A little bit. See, one or two values are outside this, but more number of values are falling within this range. So the average gets closed down, and thereby the deviation is also a little bit nearby that. So if I plot that, if this is the mean, if that is the mean, so there is a deviation possibility of 2. This is 10. So it can either go to 12 or it can go to 8. So the values, the cost per unit in our example will range or shuffle between these two upper limits and lower limits. This is your lower limit and this is your upper limit. You are able to understand now Six Sigma, standard deviation, how it functions. Standard deviation is the deviation from the mean. How far from the center are the values moving, right? Okay, now in this particular example, if you see carefully, the highest value is moving within 2 sigmas itself. See, first sigma is 21. If you add upper limits, first sigma takes you to 21.067. Second one takes you to 26. Right? Your highest value is only 25. That means only 2 sigmas higher you are going. You are only going maximum of 2 standard deviations. And if I am going to bottom, like from here, if I go down, I'll go with a 4. Okay. What is my standard deviation in this example? 4.7, right? 4.74. Okay. So it will be somewhere around 12. And then if I go again 4, it will be somewhere around 7.5 something. And even if I go below that, right? But if you see here, my lowest cost is what? This value. This is my lowest cost. Lowest cost is somewhere between 10 and 15. So if you think logically, it is less than 1 sigma on the lower side, and it is less than 2 sigmas on the upper side. Six Sigma states that the maximum allowed deviation is 6 sigmas on either side. Maximum allowed deviation is 6 sigmas on either upper side or on the lower side. You are able to understand now? Sigma is the deviation from the center point, deviation from the mean. If suppose my mean is 30 and my actual point is 33, that means 3 points it is deviated from the center origin. So what we will do is we'll calculate the sigma by using the average concept and square root of x minus x bar whole square sum of that, and then what we'll do is we'll identify the sigma. So from the mean we will go 6 sigmas on the upper side and we will go 6 sigmas on the lower side. So the maximum range shall be between these 6 sigmas. It should not go beyond this upper side or should not go beyond this on the lower side. That is called as 6 sigma. So the maximum allowed losses, or sorry, maximum allowed deviations from the standard are 6 sigmas from the mean. Your textbook says 3 sigmas on the lower side, 3 sigmas on the upper side. That's absolutely wrong. Okay, so don't follow that. Unfortunately, that is what is given in your textbook. I would suggest you not to follow that. Okay, next one. Sir, what does 6 sigma try to implement? 6 sigma tries to reduce your mistakes or reduce your deviations from the standard process. Once a 6 sigma is successfully implemented in an organization, it reaches a point where 3.4 defects per million iterations. Means if you conduct a production process for a million units, if you produce a million units, only 3.4 maximum defects can be allowed. If a 6 sigma is successfully implemented, since the deviations from the standards are reduced to 6 sigmas on either side, it means your maximum allowed defects will be 3.4 in every million. That is like almost all 96.666666666% of accuracy. Right, you are almost all getting 96.9. It is 99.999999666% of accuracy. Right? See, let me just calculate. 3.4 in 1 million. Right? 3.4 divided by 1 million. That is 99.99966% of accuracy. 99.999 99.99966% of accuracy shall be achieved in an organization. Sir, imagine the implication of that. Like out of 1 million units, not even four defects will be there. That's amazing, right? But sir, how do we achieve that? How do we step forward into Six Sigma? Before seeing that, let's just understand some theoretical concept, right? Chalo guys, see. Six Sigma is a quality management program that was pioneered by Motorola in 1980s. Then you have the aim is to achieve a reduction in the number of faults. As I told you, number of defects shall be reduced within a tolerable level of 6 sigmas on either side. Next one, the sigma stands for standard deviation, which I have explained, and they say that for reasons that need not be explained here, I already explained those reasons as well. It can be demonstrated that if the error rate lies beyond the sixth sigma, means the chances of defects going beyond the sixth sigma are 3.4 out of 1 million. Able to understand, ma? See, for example, if I take this as an example, okay, so what is my sigma here? Sigma is 2. So 6 sigmas on the higher side will take me to what? 16. 6 sigmas on the lower side will take me to what? Oh, sorry, not possible, na? Okay, we'll go with sigma of 1 here, for example. So this will be 1, this will be 9 and 11, this also will be 9 and 11, and now here 6 sigmas on the higher side will be from 10 to 6 sigmas. Each sigma is 1, so it will take me to highest of 16. From 10 to lower side, it will take me to maximum of 4. Okay, so now if 6 sigma is implemented, and you produced 1 million units, the chances of the cost per unit, okay, out of those 1 million units, only maximum of 3.4 units will have a per unit cost of above $16. Now you are able to understand now how exactly Six Sigma functions. The chances of a deviation of more than the 6 sigmas for 1 million units will be only 3.4. So if I produce 1 million units, 99,999.67 units will be, 99,996.66 units will be within the range of 4 and 16. Only 3.4 units will be outside the range of 16 or 4, either lower side or upper side. Understood that? So in another language, it tries to bring your per unit cost very close to average cost. So the number of defects or number of deviations from the original process will be reduced to very tolerable level of 3.4 out of 1 million. See, fewer than 3.4 defects in every 1 million units that are produced. Okay, sir, can you take another example? Another example and try to tell us. Okay, see, for example, if I go to a hospital and the waiting time in a hospital ranges between half an hour to 45 minutes for an example. So there are total, okay, I'll just take an example with an Excel and I'll show you, because previous example had a little bit of huge deviation because I took 10 to 25, only 8 samples and the differences are 10 to 25. So that's a big gap is there. So if I have to increase the number of sample or I have to reduce the gap. So I'll try to do that now with a different example. I'll try to explain. So just give me a second here, guys. Okay. So I'll go waiting time. Okay, and we will do it. The waiting time ranges between 30 minutes to 45 minutes. Okay, and let's do it a huge number of times so that you can actually understand the the impact of that. So I'll go with some 105 samples. Okay. Okay, so we have the waiting time per customer recorded for the last 15-20 days or whatever it is. Okay, so let me just go with this. Okay, so we took a track of total 100 patients and each patient waiting time has been recorded. So we got the waiting time here. Now what I'll do is I'll just calculate this mean here. Okay, so mean is equal to average of all these numbers, right? So I got a mean. So on an average, the waiting time for per patient is 38.3. Now what we'll do is we'll calculate x minus x bar. Okay, x minus x bar. I'll do whole square as well. So is equal to x minus x bar whole square. Okay, so we got x minus x bar whole square. Very good. So the next step is to sum up all of them. Correct? Sigma of x minus x bar whole square we got. Okay, then what this has to be? There need to be a square root that is applied to this. SQRT of sum of x minus x bar whole square. So how the hell is it 48? Okay. Oh, by n I have to do now. By 100, right? We did 100 number of sample, right? Okay, cool. So our standard deviation is 4.87. I don't know why we are getting 4 point something. It is 4.87 this time as well. Okay, so it means, see how to understand this, sir. On an average, per patient waiting time is 38.3. But it can be 4.87 minutes faster or slower. Okay, and if I collect the data of 1 million patients, the chances of those deviations going beyond 6 times of this deviation, this into 6, that means 29 minutes excess delay, 29 minutes more delay. Actually, on an average, you will take 38.3 minutes plus surplus delay, that means over late of 29 minutes. So the chances of a patient waiting for more than 67.53 minutes is 1 out of 1 million patients, only 3.4 patients will be having a waiting time of 67.53 or more. Now I don't think there will be any more doubts for you guys. I think I explained the concept very clearly, right? I really hope that you guys actually got the picture here. So let's just move forward. See, you can see on this particular graph how it actually works. You start with your mean, you calculate your sigma, and you identify the gap between your actual mean and maximum of 6 sigmas, and then your process will be moving between these ranges. Okay, right, and the chances of anything going beyond this 6 sigmas is 3.4 out of a million transactions or million iterations. Okay, sir, with that, now let's understand this. So all this is done. This is a tolerance level that is set. 6 sigmas is the tolerance level, and almost perfection will be achieved because customers will have room to complain fewer than 4 times in a million. Sir, why? Because we already intimated our customers that maximum waiting time is this much, but there are chances that 4 out of a million customers will have a waiting time of maximum of 65 minutes, as in our previous example. So chances of complaints will be very less. Now, first of all, sir, how can I implement Six Sigma? So in order to implement Six Sigma, you need some characteristics. First of all, you need to understand what the customer wants. First, always start with customer centric, means first identify what is the maximum time customers are willing to spend, wait, or what is the maximum cost that the customers are ready to pay. So first identify your customers' requirements. Second one, your management should be dynamic. They should be ready to change. Your employees should be dynamic. They should be ready to change. You should undergo an employee training program. So teach them that the number of defects should be less than 4 out of a million to make them understand how the deviations work and how, what are Six Sigmas and other stuff. So they need to undergo a process training and other stuff as well. Next one, Six Sigma is not a standalone tool. You have to implement Six Sigma along with other tools like JIT or TQM or BPR or something like that. You cannot just implement Six Sigma and think that you will get complete results. Yes, you will get good results, but you also need it to be integrated with other quality, what do you call them, practices to get best results. Okay. Next one. See this. Six Sigma should be focused on the customer. It should be should be related to the main drivers of performance, what you actually want to achieve. Your Six Sigma implementation should be more targeted towards what you want to achieve. Where do you want perfection levels? Okay, and maximize it. It should be a part of a wider performance management program like TQM and all. Senior managers should have a very key role. Training and education is required for the management and employees. Six Sigma sets a target. It sets a target that maximum deviations are 6, but it does not say that you should not go beyond this. It still allows a little bit of what do you call it, space for failure. It says that out of a million, 3.4 times you can go beyond this 6 sigma, only 3.4 out of a million times. So it's not 0 defects, it's 3.4 out of a million defects, right? Next one, there are some criticisms or limitations for this as well. What are those, sir? It gives you a very tight schedule, so like the number of defects are very less, 3.4 out of a million. So employees might feel a little suffocated because of too much control over them, right? And it depends on the past data, like I have shown you in the Excel sheet. Like first you need to track a million data to understand what is our standard deviation, what is mean, and what is all that stuff. With less data, if we do that, like the first example what I showed you, cost per unit, I took only 8, so there was a huge deviation over there. But if I increased it to 100, the deviation reduced a little bit. If I increased it to 1000, the deviation would be much more lesser. So based on that, you have to understand that, right? It depends on the past data. Garbage in, garbage out. Pardon me. Garbage in, garbage out. If you enter wrong data into the system, then calculations will be wrong. Six Sigma will be wrongly calculated. Deviations will be wrongly calculated. Next one, there are judgments that are involved. It is very time consuming and very expensive as well. There are lots of efforts that need to be put into this, and then it needs to be implemented across the organization, not just in one particular aspect of the business. It should be a part and parcel of your entire business, which is very difficult to achieve, right? And the most important one is, we are assuming that before implementing a Six Sigma, we are assuming that customers are okay with our product, customers are happy with our existing process. All we need to do is just reduce the defects. But if customers are not happy with the existing process or the product, then implementing Six Sigma and reducing the defects is useless, because they want something else. You are producing something, they want something else. Just because you are producing it very good, very effectively, doesn't mean they'll consume it. You go to a sweet shop and you ask them, sir, I want gulab jamun. They said, sir, gulab jamun is not there, but our kova is excellent. Okay, it's like the best in the world. Will you have it? Like, you will be maybe trying it or something, but what you need is different from what they have. So just because they have best in the class, or just because they have 0 defects, doesn't mean you will consume it as a consumer. You want something else. So first, the management has to make sure that the existing process and the product is what the customers want. Then we need to try to reduce the defect level. Right, sir? Okay, now comes the most important concept, that is how to implement Six Sigma. What are the steps or stages involved in Six Sigma, sir? First of all, I would like to bring to your notice that there is a word called as lean here. In the next lecture, I will talk about lean separately. See, lean is a part and parcel of Six Sigma, but I'll cover lean separately so that you can get a bigger picture about that. Okay, first let's talk about Six Sigma, then we'll talk about lean in the next lecture. So now there are 5 steps that are involved in Six Sigma, that is called as DMAIC. Okay, see, previously we used to have 2 types of Six Sigma strategies. One is for existing processes and the other one is for new processes. Okay, so there used to be a concept called as DMADV as well. Okay. Okay, it's not working now. Okay, there used to be something called as DMADV. Okay, so but that is not applicable anymore, that is gone. So let's just stick to DMAIC, which is a part of your syllabus. Sir, what are this DMAIC? D stands for define, measure, analyze, improve, control. Define, measure, analyze, improve and control. DMAIC, define, measure, analyze, improve and control. Sir, what does that mean? First of all, step 1, define the existing problem. What is the mistakes? What are the mistakes that are happening in the existing system? Define the problem. Analyze the impact of that problem and identify the root cause for that problem. Okay, first measure it, means what is the impact of that. Then analyze that, what is the reason for that problem. And then improve it and control it. Improve means reduce the chances of defect. Apply a solution and reduce the chances of defect. And then control that. Make sure that the new system is implemented successfully. Okay, for example, let's just say, hypothetical example, and not related to the real life. Just hypothetically, I started my SBR first batch, for an example. My first batch students, everybody failed. Everybody failed. Hypothetically, yeah, till date we have 100% pass rate in SBR, so don't even try to point out that. Okay, till date, every single student of mine, exception to one who scored 49, unfortunately, but everybody else passed, so it's near 100%. Okay, anyways, let's just assume my entire first batch of SBR failed. Now, first step in application of Six Sigma is that define the problem. Like, why did they fail? I mean, the failure of the students is the problem. Next one, measure the problem. How many students appeared for the exam? How many actually failed the exam? Next, analyze the problem. Identify why the students failed. Improve it. For example, maybe I was not teaching properly, or maybe I was not solving the past papers, maybe I am not giving exam techniques. Okay, which is none of the cases, none of them are applicable in real life, but assume. Now I identified the problem and analyzed the reasons for the problems as well. Now what I'm going to do, I'm going to improve that. How am I going to improve that, sir? Rectify the problems that are identified. Now start solving exam kits, start teaching practice papers, start teaching them exam techniques and all in the real classes itself. Then control that. Make sure that I repeat that for every lecture and I repeat that for every batch, not just once implementing and leaving it like that. So those are the 5 steps that are involved in achieving Six Sigma. What are those, sir? DMAIC. Define the problem, measure the problem, analyze the reasons for those problem and root cause for the problem, improve the problems by creating solutions, and control the processes by maintaining the solution for upcoming activities. Clear with this? Chalo. Next one is, how does Six Sigma improve the quality, sir? Very simple. You focus on the customer, you try to reduce the defect, so your cost will be saved and businesses will be improved, right? See, increased focus on customer, identification of the business process improvements, management decision making is driven by data and facts, not just by assumptions. Now we calculated the data, we took the mean, we took the average, we took the standard deviation and all. So it's data driven. Next, the proactive involvement of the management, like even before the complaints are received from the customers, we implement the Six Sigma to reduce the number of defects. So that's proactive. It involves collaboration across functional and divisional boundaries. I told you Six Sigma has to be implemented across the organization, not just in one process. And the increased profile of quality will increase your brand image and your trustworthiness as well. See, when you implement Six Sigma, people will be knowing that, okay, this organization has less than 3.4 defects in a million. So they are much more qualitative and they are much more efficient. So let's go with them. So there comes a brand image for you as. I could have completed this lecture in 15 to 20 minutes if I just explained DMAIC, advantages, disadvantages, criticisms and all. But it took me more time to actually explain what is deviation, what is sigma, what is all that. So it took me more time for that. I hope it's actually productive and you guys actually like this lecture. If you like this lecture, ping me that, sir, Six Sigma is awesome. Right guys? Chalo, we'll see you soon in the next lecture with Lean. Until then, take care. Bye-bye.